My name is Marc Fuehrer and I'm a Senior Product Manager for LC Supplies at Agilent Technologies. In the last years, I've worked in various positions around liquid chromatography. First in the field as a service engineer during several years, then in the LD division as a worldwide support engineer, then in the software to develop a diagnostic software for LC instruments, and finally in marketing supplies. In this webinar, I will speak about different barriers to productivity in HPLC and how to best overcome them by applying regular system maintenance and by using Agilent LC Supplies. During this webinar, you will get a better understanding on how to reduce the repair cost for an Agilent LC system with less downtime days per year and by fewer unexpected repairs, typically by recognizing symptoms and identifying issues before shutdowns. An LC system can be used every day or only periodically, shared with a group or individually, and there are many barriers that comes up and can limit productivity. You may come into the lab and not know what state the LC is in. How was it left? Who used it last? How old the solvent is? Is it still good? If your system isn't running properly, your data may be unreliable and require troubleshooting or rerunning samples. You really will want to minimize all these barriers and prevent problems to achieve optimal analysis. Productivity is strongly affected by different barriers, and we can classify them in different categories. The unexpected downtime, generally coming from parts wearing and clogging in the flow path. The chromatographic issues, which are generally due to bad connections in the flow path or misuse of solvents. Good practices in HPLC will strongly help to reduce the most frequent barriers and will help to keep high productivity. And Agilent has definitively good solutions to overcome these barriers, and in the coming slides I will address them. Overcome barriers to productivity. I have identified 6 main topics which can help to overcome them. They are listed here on this slide, and during the webinar, we will go through each of them, highlighting their importance. Some parts in the HPLC system have to be replaced on a regular basis. Knowing your system, which HPLC system, which modules in the system, which supplies, is key to keep the productivity at the top level. Identifying the maintenance parts and doing a regular maintenance using the kits will help to reduce instrument downtime. Knowing how to find the right supplies on the Agilent.com web page will help to best manage the productivity. And finally, understanding the flow path in your HPLC system will avoid long and costly troubleshooting in case of a blockage or a leak in a capillary or in a connection. Ensure you use Agilent InfinityLab products. The InfinityLab family consists of InfinityLab instruments, InfinityLab supplies, InfinityLab columns. All these products have been tested together in a full workflow approach to ensure best results and reduced operational cost. This will be a key factor for improved lab efficiency and to control operational costs. On the supply side, many InfinityLab families are currently available, including fittings, stay-safe products, lamps, valves, heat exchanger, maintenance kits, valve plates, etc. These products can improve usability, flexibility, lab safety, or traceability, thus maximizing your LC analytical efficiency. All these products have been tested together on Agilent instruments to ensure best performance. Why performing preventive maintenance? Chromatographic symptoms visible with a change in peak shape or a change in pressure or ripple or noise are forerunners for issues on your LC system. Regular maintenance on your system with exchange of wearing parts like needle seat, rotors, frets or seals before they are damaged is the right approach to achieve optimal analysis. We see here that regular maintenance helps to identify problems before a shutdown, reduce by 24% unexpected repairs, and lower by 31% the repair costs. A recent 5-year study with more than 38,000 service calls has estimated a 2.5 fewer downtime days per year when doing regular maintenance on an LC system. For an easy system setup, the InfinityLab Flex benches increase the flexibility and reduce the repair time. The different setups, benchtop on a lap bench, flex bench on wheels to ensure mobility, FlexBench MS specific for the use of the InfinityLab MSD and Ultivo LC MS systems, are idle to ensure that the maintenance on the system can be done easily and with the best access to each module. I really encourage everybody to think about the use of a product from the FlexBench family to improve all maintenance and repair activity on a system. The main measure of system performance for your LC is the system pressure. Always keep an eye on your system pressure. Even when your system is working properly, it's helpful to record the system pressure. This can help you identify quickly a change in your system and the need of a preventive maintenance. The pressure ripple can be monitored, and this is a useful diagnostic tool. If you are pumping the same mobile phase composition on an equilibrated system, the pressure ripple should not fluctuate widely. If there is excessive pressure ripple, there may be an issue with the pump. Looking at the behavior, whether it's rhythmic or erratic, and how large the fluctuation is, will drive the troubleshooting in a specific direction. Choose the right pump maintenance kit from the table below. It includes the right maintenance parts for your specific pump model. Since your autosampler is where your sample gets injected, this is a major source of contamination and carryover from run to run. You might see ghost peaks that show up randomly within your run, high back pressure or inconsistent responses. Any or all of these problems can be caused by a lack of preventive maintenance. That's why it's critical to set up an LC instrument maintenance program and to keep essential supplies in stock for regular replacement of worn or damaged components. Common sources of autosampler issues include the exterior of the needle, or worn needle seat, or worn rotor seal in the injection valve, or a poorly made fitting. To simplify your life and operating your autosampler at its best, I suggest to choose the right autosampler maintenance kit from the table below. Each of them includes the right maintenance part for your specific autosampler model. When starting to think about the instrument flow path, it is important to understand the flow direction. The instrument setup may be different, but the flow path will be the same, going from the solvent cabinet to the degasser, the pump, the sampler, the column compartment, and finally the detector. Make sure you know the path of the flow in your instrument setup when you encounter chromatographic symptoms, which could be related to a blockage or a leak in your system. This best practice will help to reduce the troubleshooting procedures and keep the productivity under control. All separations start with mobile phase. What is in your solvent bottle is extremely important. If there is any contamination here, it will carry through and even accumulate in your system. That can set you up for a very long and frustrating troubleshooting session. Things you might in your LC analysis related to solvent contamination are ghost peaks, higher back pressure, degasser problems, even column lifetime issues as debris or microbes collect on the inlet of your column. Let's avoid this. Definitively use HPLC or even MS-grade solvents, depending on your sensitivity requirement. Use clean glassware. Rinse it with a bit of mobile phase before you fill it up. You can use a solvent inline filter to catch larger debris or dust that might happen to be in your bottles. But there is no substitute for good, clean lab practices here. If you are using any buffer or salt solutions, it's a good idea to filter your mobile phase, but be sure the filter membrane material is compatible with your solvent. Aqueous mobile phase is a perfect host for microbial growth, especially sitting in a warm lab or in sunlight. Microbes are tiny and can accumulate in the smallest corner of your system or even pass through the column inlet fit and into your column, causing system contamination and high back pressure. Don't let aqueous mobile phase sit for many days. It should be replaced frequently. You can always add a small percent of organic solvents to your mobile phase, like 5%, to inhibit microbial growth. There are also amber bottles that can help reduce light exposure to your solvent. Particles are everywhere in the flow path. They are accumulated in the flow path. They end at the column or the detector. Here we can list the unfiltered particles in the mobile phase, the dust from the air, bacteria, the polymers from organic solvents, the particles from the sample or the standards, the worn system parts. Particles are responsible for most of the issues in an LC system. On this slide, we can see typical issues in the flow path and how they look like in reality. Dust via open solvent bottles, algae growth, salt precipitation at different areas in the flow path, like on the purge valve, on the injection valve, on the flow cell, or on the pump head. Why should HPLC users use inline filter? Particles can come from everywhere in the flow path. Solvents, samples, or worn instrument parts such as pump frits or rotor seal of injection valves. Over time, particles can clog the column frit, causing pressure increases that damage LC columns and shorten their lifetime. An inline filter protects valuable columns by capturing particles before they reach the column, extending their use and reducing the cost per sample. The chart at the bottom right shows the result from our accelerated lifetime test. We can see how the pressure increase caused by particles can be quickly and easily eliminated by replacing the filter disc. You might know the current inline filters of Agilent, the 1290 inline filter and the RRLC inline filter. The new InfinityLab Quick Change inline filter is the updated version that has a much better usability and robustness than current filters. It enables finger-tight, tool-free replacement of filter disc and has a click and seal mechanism that I will show you in a moment. Let me play this short video to show you how easy it is to replace the filter disc. Simply open the filter housing by turning, easily remove the used filter disc, insert a new filter disc using a touchless packaging. Close the filter housing by hand until hearing a click. This click sound ensures the filter is sealed for up to 1300 bar. Thus, there is no risk of over or under tightening. Besides, since the torque to tighten the filter housing is so small, the filter housing won't be damaged at all after over 100 replacements of filter discs. As shown on the chart at bottom right, the plate's count of chromatographic peaks stays stable over more than 100 installations of filter discs into on filter housing. We offer a variety of dimensions and porosities of filter discs to 3 different needs of customers. Filter discs are available in 2.1 mm inner diameter with 0.2 and 0.5 micron pore sizes, and in a 4.6 mm ID with 0.2, 0.5 and 2 micron pore sizes. As just shown in the short video, we designed a unique touchless packaging to enable a no-touch insertion of filter disc into filter housing to avoid potential contamination. Besides, the filter disc can be replaced without disconnecting the inline filter from the system. Starting from approximately May 21, there will also be a new feature in Smart Alert for the inline filter to remind users of replacing filter disc based on time, interval, or number of injections. If users have some experience on how often they need to replace a filter disc and would like to do the replacement before dogging happens, then they can activate the Smart Alert feature. Taking some basic precaution with mobile phase helps to reduce typical chromatographic problems like contamination, ghost peaks, high back pressure. The purity of the solvent is a key parameter to take in consideration when choosing a solvent for HPLC or LC-MS application. The material in the flow paths are primarily stainless steel and PEEK. All solvents which can react with should be avoided, or if not possible, a more regular maintenance of the concerned parts should be scheduled. The presence of algae in water media can cause various problems with HPLC. Buffers, light, and pH value between 4 and 9 will accelerate their draws. Using freshly prepared and filtered water reduces the occurrence. Including a small percentage of organic solvent in the water phase and using the brown solvent bottles reduces consequently the risk of algae growth. To reduce and avoid problems coming from the flow path, Agilent recently introduced the purging bottles. Purging is now easily possible with no leaching of harmful solvent vapors into the air. Solvent lines can easily and safely be put in or pulled out of the bottles, and no risk of suction of air into the flow path. I'm not sure about your hands, but my hands are kind of small, and those big mobile phase bottles can be a little hard to grip, especially if they are full of solvents or if they are wet. There are new solvent bottles available that have a narrower core, making it easier to grip. These InfinityLab solvent bottles are much easier to handle, and you can add InfinityLab Stay Safe cap to prevent solvent evaporation and to better manage your solvent lines. The Stay Safe caps prevent solvent evaporation, which is great for those organic solvents that do sit on your system for some time. Organic solvents and some additives are volatile, affecting the percent composition. Sometimes even a small change in composition can affect your separation, so it's best to be safe here. The stay safe caps can also be used on the waste can to avoid any solvent evaporation. InfinityLab stay safe caps have a handy time strip that will tell you when to change the filter. Approximately every 6 months, depending on the solvent and the use. The fittings. Proper seating of fittings is of utmost importance through all your LC connections. If the tubing extends too long past the fitting, the ferrule cannot seat properly and leaks will occur. If the tubing is too short past the ferrule, a dead volume is created and mixing can occur in this tiny void. This can broaden or split peaks or cause tailing, especially on early eluting peaks. It can also be a source of carryover. A properly installed fitting is perfectly flushed with zero dead volume. We can see a chromatogram that shows the impact of just one poorly installed fitting on an LC system, resulting in consistently poor peak shapes. Less stress, more reliable connection. With the InfinityLab Quick Connect fittings, you can be sure you are getting a perfect column connection every time. Turn the blue nut until you feel some resistance. Close the lever. The proprietary Agilent design features a spring-loaded mechanism for zero dead volume and a sure, tight connection to 1300 bar. The InfinityLab Quick Connect fitting is very well suited for low dispersion applications due to its guaranteed zero dead volume connection through the spring-loaded design. It's most beneficial for R&D, method development and contract labs, where users need to replace column frequently, since it's much easier and faster to use than a standard fitting. The InfinityLab Quick Turn fitting has a similar design as the InfinityLab Quick Connect fitting, just without the lever. It is finger tight up to 400 bar, and with the use of the mounting tool, you can get up to 1300 bar. The importance of the lamp. Here we have an example comparing a lamp from Agilent with a lamp from another source. As you can see, signal to noise is significantly better with the Agilent lamp. Also, the baseline drift is a real problem with this competitor lamp. So the lamps might look the same, but they are definitely not the same. Agilent lamps have been designed and optimized for each detector, which ensures best chromatographic results. Restart the system. Restarting a system after a longer shutdown can become a nightmare. To avoid such critical situation, a step-by-step approach can help to overcome these different barriers. Step 1. Conduct a preventive maintenance. Step 2. Run a checkout sample. Step 3. Conduct diagnostic test to check the system wellness. As diagnostic test, we recommend a pump leak test, a system pressure test, a detector intensity test, and also very helpful is to monitor the accumulated UV lamp on time. In the table below, you have some details on that step-by-step approach and a checklist of things to do or to verify. It's very important to have a segmented approach and address first all topics related to the system itself. Then think about the mobile phase, then the pump, then the column, and finally the detector. In the next two slides, you can find some common issues after a shutdown and how to overcome them or which solution best fits. We see here that most of the common issues are related to the mobile phase, alga in the mobile phase, air in the flow path. And here on the second slide, things which are going in the direction of crystallization in the flow paths which are blocked. So principally flow path issues are the most common problems you can have with an LC system when you turn it on after a longer time off.